In this video, I'd like to demonstrate how to support a slab on piles with a beam around the edges. So we've got here a model I'm looking at, and if I just show here rendered, if we look at this model, I have beams around my perimeter of my model. And I'm looking at those beams here, and there's a slab interior. If I unselect that slab, you can see I just have a mesh of beams. I've drawn them in as segments. So they're now here currently supported by these piles. I'm going to go ahead and look at this unrendered for a second. And we can see that they are drawn here. Those piles are just supporting at the points right there. Those piles could be supporting anywhere, actually underneath the grade beam. But since we have a slab as well, the slab could be also a point of support for those piles as well. So those piles could go anywhere inside of that slab. I'm going to go ahead and show that slab again right there, just selecting it. So those piles are defined in the pile definition spreadsheet. Currently I'm using that square pile with a 14-inch side dimension there. We give the embedment here. Pile embedment is 6 inches, and then we have some of the stiffness properties of that pile. So compression capacity as well as tension capacity, and the stiffness of that as well, the shear capacity. Now, one thing to note when you're modeling a slab like this, so you are looking at the center line of these beams. So if the perimeter of the structure was out here on the edge, it would be important for you to model it so that you have offset that slightly, so you could actually have the perimeter of the structure be represented properly. So you can see that this is one type of method in order to design your structure, and if you did it this way, it would be the piece we want to find here is that beam reinforcement. So I'm just going to solve this really quickly, and you're going to see that those grade beams there are going to be designed. If we click on that grade beam, that grade beam is going to give you a design here for the actual reinforcement, as well as stirrups that might be needed here for top and bottom bars. So that's a really important piece and why you might be modeling this. The other thing that you'd be seeing here is going to be putting in your design strips. So if I go ahead and look at my design strip for a second here, I'm going to go back unrendered. I've drawn in design strips here from center line point to center line point. But if we remember, that is a actual overlap at that point. So those beams are submeshed directly to the slab, but since I have a design strip defined directly to the center line, there's just a bit of overlap between those. So it's not to worry, but if you had reinforcement, specifically highly reinforced beams, you may not need to have that design strip drawn directly to the center line because you already have accounted for all the forces at that location. So you could go ahead and delete that design strip and draw it a little differently here. Let me show you. This would be something you'd want to make your own decision based on how you think the flow of the forces are working in there, but you'd go ahead, I'm just going to show as a demonstration 2 of them. And I'm going to go ahead and take this off a render real quick. It's easier to draw, and we'll put ourselves a little drawing grid so it is also easier for us to draw this in. So I've changed my drawing grid. And then I'm going to draw in that design strip. So the design strip is going to go vertical here, vertical direction, and you might just hold it back. So I'm just holding that design strip slightly back. Now, how far back? These are all engineering decisions you'll have to make. I just sort of went with a 2 foot to account for maybe the depth of that beam. So now when I do my reinforcement design there, you'll see it's going to just show me, I run that model, and it'll just show me that it's just slightly held back. Now that doesn't change the flow of the forces, just the reinforcement design. Another method for using this type of a model would be to go ahead and use it as a thickened slab. So I'm going to jump into that new model here. And it's the same geometry here, but what we'll see, let's just look at it rendered real quick and in an isometric view. The way I modeled this model is to have a thickened area around the entire perimeter slab. So that slab right there is a 36-inch slab that represents the beams in my previous model. And then what I did is I thinned the slab here in the interior. So I used my tool here. If I go to my slabs and I'm going to break the solution real quick, opening and thickness, I can modify that slab to a certain thickness. So I used an 8-inch interior to modify that slab so that the outside is thick and the inside is thin. Now, one of the things when you do that, I use reinforcement design strips a little differently. So I drew the design strip here directly on top of my slab where that thickened area is, all around that. And then in the interior area, I used a different design strip, so it would be designed based on that depth there. So when we run this model, I'll see here, I'm going to get reinforcement design based on that information. Now, it's not exactly the same reinforcement on the thickened area because it's not considered a beam. However, I do do really like the way the flow of the forces work based on the thickness of the slabs. This is all a plate model, so you might end up with a little bit of more of a nicer transition in those slabs. It seems a little bit cleaner, although we're not getting stirrups in those beams. So depending on what your reinforcement needs are, you might want to do the stirrups outside of the program or decide to do the model in that beam method as well.